Good day, my name is David Ronin Reyes of Group 4, and for our LAB3 vlog, I'll be discussing or creating a 5-bit comparator. So before that, let's discuss what a comparator is. So a comparator is something you use to determine the relative magnitudes of two binary numbers. So it actually compares two n-bit binary numbers and produces three possible results at the outputs. So comparators are combinational logic circuits that are used to test whether word A is less than, equal, or greater than word B. So as I've said earlier, we'll be using a 5-bit comparator. So to elaborate, a comparator performing the comparison operation to more than 4 bits by cascading two or more 4-bit comparators is called a cascading comparator. So what actually happens here is we'll be using two comparators. Then the output of the lower order comparators are then connected to the corresponding inputs of the higher order comparator. So now I'll be using the Logism application as well as an Excel to show my given variables. So here we could see that I've created a truth table. So the one here below is actually a 1-bit comparator truth table. And as I've said earlier, two inputs, which are A and B, will give an output of 3, which is A less than B, A is equal to B, and A is greater than B. So as we can see, input A, which is 0, and input B, which is 0, produces an equal value since 0 is equal to 0, thus A is equal to B is equal to 1. Now, comparing A is equal to 0 and B is equal to 1, we can identify that A is less than B, so we put a 1 here, and A is not equal to B, so it remains a 0, and A is not greater than B, so it remains a 0 as well. And now let's move on to this third row, which stays at 1 and B, and 1 is not less than B, so 0. 1 is not equal to B, so 0. But 1 is greater than B, so 1. Now, similar to the start, we've discussed that 1 and 1 is equal, so we simply put 1 on the equal, and we know for a fact that it is not less than or greater than. However, this table is actually a 1-bit comparator. Now, we'll be creating this 5-bit comparator. So this 5 columns will be our inputs, and this will be our outputs. So I've actually organized it already, and as you can see, uh, this table is somehow similar to these ones. The only differences is our input A is less than B all has 1 on our less than side, while the other two columns have zeros, and we could see that in the other given variables. And we also have columns, these 3 columns that don't have inputs at all. At um, these 3 um, columns. So we could actually put here C, then D, then E. Right, I'll just arrange this home font color, this one, and then bold alignment middle there. So now with these 3 columns, when we compare this 5, we come up with these ones. And one thing we could notice is if I is less than B has 1 input for all, we would also have an output of 1 for all. Now, when we look at the green side or the greater than, we see that similar to the less than, we also get a output of greater than. Now, comparing the equal and the no output at all, we could see that 0 and 0, we get a 1. And then we could see that since 0 is less than b, our less than b is actually our high input. Now, if we compare our third third row for this group, we could compare a and b, which is 1 is greater than 0. That means our output is a is greater than b. And similar to 0 and 0, we get a 1 and 1, which are equal. So put 1 here. So we've actually see this same pattern here, which is why the outputs are the same. So now let's move on to our K-map, which I've also solved already. Now, in order to discuss properly, uh, I've created 3 K-maps here, one for the less than, one for the equal, and one for the greater than. And as we could see, the AB is on our left side and the CDE is on our area here. So actually, we've assigned the letters C, D, and E for the corresponding outputs we've seen at the table a while ago, which is these ones. So as the legend states, C is equal to A is less than B, and D is equal to A is equal to B, and E is equal to A greater than B. So I've already grouped this once, but let me explain further why there are don't care variables here. So as discussed earlier, two outputs have actually three outputs, and in order to make it valid, there should only be one high frequency for all of the three outputs. So as observed, the variables that are marked as X are those of the numbers that have two ones on it. So that means they are don't care variables. So now moving on, I already grouped these variables, these ones I meant. So for our first group, let's focus on the red, which is the this two. And as we can see, we could see that it is only occupying one row. So we get an A prime, and since it's one, B, and then we get a B prime, E prime. So that is correct. Now let's get this green row. And as we could see, it is only occupying one row, so we automatically need to copy A and B and compare if it is 1. So 0 is not equal to 1, so let's put A prime, and then 1 is equal to 1, so let's put B. And then now let's compare the values we have above. As we could see, 0, 0, 1, 1, that cancels out C. And then we have 1, 1, 1, 1. That means we have to put D. And then we have E. Where is our E? 1, 1, 0, 0, 1. So we cancel out E. Now we need to add our C. So how did we get this? We have this for variable 4 by 4 box or group. And as we could see, it cancels out this row. However, we need to compare the values for C, D, and E. And we could see that the only constant number here is the one at the first number for each. So we put C. So as I've discussed earlier, I've noticed that I've actually made a mistake here in the green group where I discussed that D is all 1, and since we have the value of 1, it should be a D and not a D prime. So we could actually edit it simplification. So as we could observe, when we simplify this, we could simplify this by actually factoring out a prime b. So we get a prime b, um, and then d prime e plus d, then plus c. So now we're done with this. Now we're done with our a less than b. Let's move on to our a is equal to b. Now, I'll start with the red group since this is the only one group here. Uh, we could say that 0, 0, 0, 0, 0 is all A, B, A prime, B prime, C prime, D prime, E prime. And now let's look at the green group. And the only difference is the A and B are 1. So it's A, B, C prime, D prime, E. Now let's move on to our yellow group. And as we could see, it's only covering one row, which is 0, 0. So we automatically put A prime, B prime. Now we have covered these 4 rows to maximize our groupings. Um, we've decided to um, compare C's, so 0, 0, 1, 1, thus C is removed. Then compared our D's, 1, 1, 1, 1, we put 1. And then our E's, 1, 0, 0, 1, since there are changes in that letter, I mean in that number, we cancel it out. Now let's move on to our last group. And as we could see, similar to our yellow group, it is only covering one row, which is the 1, 1 row. That means we automatically put our A and B there. And the only difference this time is it is not in prime. So similar to that, we only put D. Now we could actually simplify this by factoring out C prime, D prime, E. And then factoring out D for this yellow and blue group. And we actually end up with this with this uh, given equation. And since we know A prime B prime plus AB is equal to A XNOR B, we could actually leave it at as is. So now let's move on to our last came up, which is A is less than, I mean A is greater than B. So we actually have just two groups here. Uh, First is the red one. So let's first look at it. Since it is covering only our last row, we could say that it automatically inputs 1 and 0, so A and B prime. Now comparing the four numbers above that is being covered by the red group, we could see that 0, 0, 0, and 0 for CDE is constant, so we put C prime. And since 0, 0, 1, 1 is not constant, D is cancelled out, and since 0, 1, 1, 1, 0 is also not constant, E is cancelled out. This is actually a simple equation, but we could actually simplify it more. We could factor out the C prime since both groups have C primes. So this is our final equation. Now let's start doing our uh, circuit. So let's first start with our given, which is this A, B, and then C, and then D, and E. So actually, I'll just label this A. Oh, I forgot. A, this one B, and then this one C, and then D, and then E. Oh, E. So as observed, we made the use of NOT gate. So let's first start with our NOT gate. So this is our NOT gate. So I'll just label it NOT gate. 7404 NOT gate. So let's just put it here A. Oh, mistake. And then E. And we could no longer put this ones here. So D and then E. Oh, so I forgot that the VCC was here. So let's just adjust that. Delete and then delete. So now we have our NOT for the following values. Could actually adjust this one. So what we have to do now is this first equation. So we'll be needing an AND gate and then an OR gate. So let's first create this one, D prime E prime. So this is our D prime, D prime, and then E prime. We actually get that. Now we need to OR that value with our D, just our D there. And we actually get this value. Now we also need our A prime B. So let's get our A prime values, A prime, and then our B, A and B, and have we actually get that value and put it here. Now we have A prime. We actually have this part, and the only part missing is our plus C. So in order to do that, let's just get our given and add it to C. Wait, I'll just add it to C, which is also here. And this is our first output. Um, so we could label our output as A is less than B. Wait, A less than B. So let's actually check this. So I'll just use this I'll use this pointer. So as we can see, the value 0100 creates a 1. So in order to do that, to prove that, we should change this B to 1. And as we could see, it's correct. Now let's have a 01010, and that means 01010 is also a 1. Let's reset it and try again. See? And then we should try our 00. Let's just try first our 00100. It should be a 1, and it's correct. Now we should put our 011. So 00. It's also correct. And then 11100. It's also correct. And then 10100, which is also correct. So we're actually done with this one. Now let's move to this variable here. So actually, we'll need a AND gate. We'll need an AND gate. So 1, 2, 3, 4. I think we'll need two AND gates because it won't fit here. And then an OR gate. And I don't know if we'll need three. So let's just first start with our A prime B prime. A prime So we actually need A prime, B prime. And then we need that ORed. So let's just OR this one right away. OR. And then we'll need a AB, an AND AB. So let's just do that A. And then B. So we'll actually need that ORed with A prime B. So we actually get this one, which we've completed this one already. Now let's finish our C prime, D prime, E prime. So let's get our C prime, C prime, wait, C prime, C prime, and then our D prime, which is this one, D prime, connect it here, and then get our E prime, which is this one. And this is our uh, first equation. Now we need to connect it to a D. So we'll need to use this one, OR gate, and then our D, which is this one. So we'll actually need another AND gate for this. So this one is our last AND gate. There. I'll just split this one. And then let's just try to remove space, extra lines. And then we actually have that. And then we actually need this one. And we could say that we're done with this output, which we'll call our A is equal to B output. So I'll just label this as A is equal to B. A is equal to B. So now let's check if we've done it correctly. And let me just use the uh, pointer variable once again. So let's see. 0, 0, 0. All zeros should produce a 1, which is correct so far. And then 1, 1, 0, 0, 0. So that's 1, 1. It is also a 1 here. And then 0, 0, 0, 1, 0. So 0, 0, 0, 1, 0 produces a 1. And then 1, 1, 0, 1, 0 should produce a 1. So 1, 1, 0, 1, 0 produces a 1. So I think so far we're done, or we're actually on the right track in creating our circuit, our comparator. Now let's return this to 0 and continue with our third table. So for our last table, our greater than table came up, we could start with our AB prime. So we'll just need one end, and then we'll need OR. So I'll first need a C prime, the letter A, which we have here, A, A, and then B prime, which is this one actually, B prime, and then we need to OR that with our, let me just put it here, E. We need an E, which obviously is this one, and we'll not get it there, so let's just get it here. And as we could see, we already have A, B prime plus E. Now we just need to multiply or to end that with our C prime. So let's just get the result here. I mean yeah, technically it's the result. And we'll need a C prime, which we all know is this one. And not actually all of us, but which I know is this one. And we'll finish it off with our output here. And let's label this A is greater than B. So let's check our values with our pointer tool. Now let's first try our 1 0 0 0 0. So it's 1. That's correct. Now let's try our 0 0 0 0 1. So 0 0 0 0 1. Correct. And then our 0 1 0 0 1. So 0 1 0 0 1. Correct. Our 1 1 0 1 1 1 0 0 1 1 1 0 0 1, and then 1 0 0 0 1 1 0 0 0 1, and our last number is 1 0 0 1 0 1 0 0 1 0. So we're actually correct with this one. Now we're done with this one. We could actually test it out in our main. So first let's save it. So let's add our comparator here. 1 A B C D B C D E. Okay, let's add an output 1. So C D E. So I'll just label this ones A, B, and then our input. So let's just label this C, and then D, and then E. And then let's label this one as A is less than B. Yeah, it is. Wait, I'll just have to, yeah, here. Wait, I'll just need to delete this one. And we actually label this as A is greater than B. And this one finally A is equal to B. Now let's check out our table here. And let's try these, let's try these values. So 0 0 0 1 0. Wait, I'll just switch. Yeah, 1 0. So it should be a 1. Then our 0 1 0 1 0 1 0 1. Wait, yeah. And then our 1 0 0 1 0 1 0 0 1 0, which is 1, and then 1 1 1 1 0 1 0. We've actually returned, so this part is correct. Let's try the upper one. So 0 0 1 0 0, we get 1, and then 0 1 1, we get 1 still, and then we actually get that, and then 1 0 1. So 1, we still get that, and then we get this, and then you'd get this. Now we're done with these two parts of the table. Let's verify our last parts. So first we'll get 0 0 0 0 0 0 and then 1. So we're correct here. And then 0 1 0 0 1 1, still 1, and then 1 0. Let's just finish 1 0 0 1 1 0 0 0 1. Well, still 1. And then our last one is 1 1 0 0 1 1 1 0 0 1. Still A is greater than B. And the last one, which means no input for C, D, and E. Let's try 0 0 first, which is 1. Then let's try 0 1 and no inputs, 0 0 0. Our first input is A less than B, which is correct. And then 1 0 0, and then no input for this 3. We get a output of A is greater than B. And lastly, let's put 1 at both, and it's A is equal to B. So we've actually created our comparator. And I think we could check our truth table, which is actually long, but if we compare it to the truth table we've actually created here, we could verify that they are actually the same. So that's all for today. Thank you for listening. And once again, I am David Ronin Reyes, and um, that was my LAB3 vlog, a 5-bit comparator. So thank you.